Revelations made by theoretical physicist Michio Kaku regarding the latest observations from the James Webb Space Telescope, JWST, have shaken the scientific community. Launched with the goal of seeing deeper into the universe than ever before, the telescope has now made discoveries that call into question one of the most revered foundations of modern cosmology, the Big Bang theory itself. In particular, the discovery of 750 anomalous galaxies in areas previously thought to be beyond the observable universe has forced many to rethink long-held ideas about how it all began. Before continuing, don't forget to like and subscribe to our channel for new updates. At the heart of this sensational discovery is the question of what exactly the telescope saw. These 750 galaxies were not just faint spots or cosmic illusions. They turned out to be structured, mature, and in some cases remarkably developed for the time and place in which they were discovered. According to current cosmological models based on the Big Bang theory, galaxies at such enormous distances should be primitive, poorly formed, and relatively dim. However, these galaxies appeared much more developed than expected, raising the key question: how could such complex structures exist so early after the supposed beginning of time? The key detail that makes this discovery so disruptive to the previous paradigm is that the galaxies appear to be located in regions of space that, according to current models, should not exist at all. Our understanding of the observable universe limits how far we can see, depending on the time that has passed since the Big Bang, about 13.8 billion years. Light from objects beyond this boundary should not have reached us yet. However, JWST appears to have detected light from structures far beyond this boundary. This points to either a fundamental error in our understanding of cosmic distances or something even more radical: that the Big Bang was not the only moment of origin, as has long been believed. Michio Kaku, known for his work on string theory and popularization of science, framed this discovery in provocative terms. While he does not claim that the Big Bang theory is completely wrong, he insists that it now appears dangerously incomplete. The existence of galaxies beyond the limits of our universe undermines the assumption that time and space began at a finite moment. These objects challenge the narrative of a single explosion from a state of infinite density and temperature. Instead, they suggest that either the universe is much older than we thought, or it is just one bubble in a much larger multiverse. The idea of a multiverse has been discussed in theoretical physics for decades, especially in the context of quantum mechanics and string theory, but until recently, it lacked observational support. This is why the JWST data is so important. It could provide empirical evidence for a previously esoteric concept. If these galaxies are indeed outside the known universe, their existence could indicate overlapping cosmic regions or a stepwise process of universe creation, with independent Big Bangs in different parts of a single spacetime. Another possibility is that our model of cosmic inflation is wrong. The inflationary model was introduced to explain the homogeneity of the cosmic microwave background and the large-scale structure of the universe. It assumes a sudden, exponential expansion of space in the first fractions of a second after the Big Bang. However, if mature galaxies already existed during or shortly after this period, the time window for their formation becomes too narrow. This would mean that gravitational compression, star formation, and galaxy evolution occurred much faster than known physics allows, unless some pre-explosion activity prepared the ground in advance. What is particularly striking about these 750 galaxies is their diversity. Some of them have a spiral structure, others are elliptical, and many display active galactic nuclei with supermassive black holes emitting intense radiation. Such a degree of complexity implies not only rapid formation, but also long periods of evolution. For this to be possible, either time flowed differently in these areas, or these galaxies are remnants of a previous cosmic cycle that somehow survived or reappeared within our observable region. The implications extend beyond a rethinking of cosmic history to the very nature of physical laws. If these galaxies formed under conditions radically different from those of our early universe, they may obey different versions of physics, different values for constants, different particle interactions, or even unknown forces. The idea that the laws of physics may be heterogeneous throughout reality is deeply disturbing, as it challenges the principle of cosmological homogeneity that underlies physics. These discoveries also bring us back to the question of the nature of time. In current models, it begins with the Big Bang. But if there are galaxies that predate this moment, what does that say about the origin of time? One possibility is that time is not linear and singular, but cyclical or branched, with coexisting or repeating timelines. Some speculative models, such as conformal cyclic cosmology, suggest that the universe undergoes endless cycles of birth and rebirth, each leaving subtle traces in the next. The JWST discovery could be the first tangible confirmation of such cyclicality. There is also a possibility that current models of cosmological redshift are incorrect. Much of what we assume about the age and distance of objects in the universe is based on how much light is stretched due to the expansion of space. If our assumptions about redshift are wrong, these galaxies may not be as distant or as old as we think. However, this explanation seems increasingly unlikely, given that different data sources point to the same thing. These objects should not be where they are, and yet they are. Another disturbing consideration concerns the very concept of an expanding universe. New data suggests that space may be expanding unevenly, or not expanding at all in some directions. If these galaxies are in static or differently evolving regions, the expansion model may only apply to part of the cosmos, not the entire universe. This idea completely rewrites the laws of general relativity as they apply to cosmology, introducing anisotropies or tears in the very fabric of spacetime. The James Webb Telescope was never designed to directly test the Big Bang theory, but its ability to observe in the infrared spectrum with unprecedented accuracy has made it an unexpected truth detector. As new data comes in, it is becoming increasingly clear that the universe is much more complex, ancient, and structured than the simplified models of the early 20th century allowed. If the Big Bang theory is a map, then the JWST is showing us areas that were previously considered inaccessible or impossible. There is something poetic, almost mythical, about the fact that a glimpse into the void revealed not emptiness, but order, ancient structures that hold secrets older than the supposed dawn of existence. This forces us to rethink the origin of the cosmos not as a single explosion, but as a continuous process or superposition of realities unfolding in a fractal pattern through infinite dimensions. Each new JWST image may not just be a picture of a distant star cluster, but a window into another version of existence. This discovery also forces us to rethink the anthropic principle, the idea that the universe appears finely tuned for life because there are observers in it. If galaxies form and evolve in conditions different from ours, beyond our observable realm, then the uniqueness of our universe is called into question. Perhaps our universe is just one of countless variants, each with its own history, trajectory, and potential for life. This does not diminish our place in the universe, but rather expands the scale and richness of the cosmic canvas of which we are a part. There is irony in this. Scientific instruments created to confirm theories often end up disproving them. The JWST was launched to help us understand the formation of early galaxies and dark matter. Instead, it may herald a new cosmological revolution that will eclipse even the Copernican and Einsteinian shifts. What it shows may not be the final answer, but the introduction to a new chapter in the history of all that exists. And yet, perhaps the most profound implication of this discovery is philosophical. If the Big Bang is no longer the beginning, then what is? Are we doomed to forever search for a phantom starting point that does not exist? Or are we finally approaching an understanding that the beginning and the end are human illusions, useful for storytelling, but meaningless in the boundless, recursive, evolving totality of the cosmos? As science advances through such discoveries, the boundaries between physics and metaphysics are blurring. The tools of astronomy are beginning to resemble philosophical instruments. We are no longer simply mapping stars and galaxies. We are questioning the very fabric of reality. The 750 galaxies spotted by JWST may not only rewrite our history, but also force us to rethink the very definition of the universe, where it begins and how far beyond its limits the truth lies. Such moments in science are rare, when observation so powerfully collides with expectation that something must give way. The Big Bang Theory has been the foundational story for generations of physicists, but every story has its limits. With data coming in from the farthest corners of time and space, a new story is beginning to write itself. Not a story of a single explosion, but of multiplicity, recursion, and unfathomable depth. These discoveries require not just new physics, they require new imagination. What we see through the JWST is more than just ancient light. It is a challenge to think bigger, to move beyond single narratives, and strive for multiple, layered understandings of reality. The Big Bang may not be dead, but it is no longer alone. And on this expanding cosmic horizon, a much more complex universe is beginning to unfold. One that eludes simplification and promises wonders far beyond anything we could have imagined. If you liked this video, please like and subscribe to our channel. Also, leave a comment below. What do you think about the James Webb Telescope data refuting the Big Bang Theory? Your opinion is important to us. Thank you for watching, and see you next time.